Hey everyone, welcome. Do you hear me all right? Let me know if you can't hear me. Welcome all, we're gonna get started pretty soon. Feel free to say hello, network, while we're waiting. So yeah, just basically right now we are getting ready to start. We are just basically inviting everybody in. So some people are waiting to be admitted. Hey Josh, how are you doing? We've got the speaker now.
I'm good. How are you?
Good, good. Good to see you. How are you doing?
I'm excited. Also setting up the PowerPoint, trying to get it to work on my Mac, which is unusual for me. So apologies if I'm swearing at the computer during the presentation.
That's fine. I don't think we have any little children in the house today. I hope not. We've got one more speaker. Cool.
Hi there. Sorry, didn't
Hey
want
there.
to disrupt.
No, I saw your picture on the meetup, so I wanted to make sure it said hi.
Yeah, same person, just different hair color.
All good. Yeah. All right, so are you going to be presenting as well? Do you need screen sharing ability?
I think that's probably easiest. Yeah.
Okay, so let's go ahead for sure. I'm gonna make sure I get both of you some permissions. Sylvana, let's see here. Am I saying it right, Sylvana?
Yeah, that's perfect.
Okay. All right, cool. All right, so yeah, like I said, I'm just basically making sure people can get admitted, and I'm going to be doing that, throughout the night because people kind of show in like different intervals. What's y'all's like, strategy towards like answering questions? What do you want people to do till the end of the presentation to take questions, or do you want them to like chat? What are you feeling?
Speaking just for myself, I'm down for people to post questions in the chat, and I can answer them in real time if I think they'll flow well, and otherwise I can like wait to answer them until I think they will. Sylvana, does that work for you?
Yeah, I'm totally down for asking questions as you go, because I know when I'm an audience member, sometimes I end up with too many questions that go unanswered. So, but I will say that I'm pretty bad at checking the chat. So Josh, while I'm talking, if you could like monitor the chat for me, that'd be great.
Tag team it likewise.
Yeah, and I'll be here to help with that as well. So, all right, cool. I think we have some good attendance so far. I'm going to go ahead and just start doing a little bit of the usual promo about the group. And then I will go ahead and move into your presentation. So I'll go ahead and share my screen now. And let me know if you can see my screen. If not, then I'll have to just do this again. Everybody see the screen okay? Cool. All right. So my name is VJ. I am an engineer like all of you. If you want to network with me, you can find me on LinkedIn. And I'm just going to send this to everybody in the chat. And basically connect with me there. And what I do is, like I work programming just like all of you. I've been doing programming for years. I started a group called JavaScript LA back in the day, and that was in Los Angeles. That's why it's called JavaScript LA. And so basically, like, we had meetups, you know, and then we kind of evolved over time to doing stuff more, you know, software engineering focused. And so the website is javascriptla.net. Basically, you know, here's some information on how to find us. This is the presentation we're doing today. We try to have meetups, you know, that flow once a month, but sometimes we kind of do more than one a month. So that's kind of like our pattern at the moment. Every meetup is now online, so you don't have to actually live in LA to see a meetup. You can just attend a meetup straight through Eventbrite or meetup.com or even through our website and just check them out on Zoom. And that's going to be the flow for quite a while. I think we may bring back physical meetups at some point too, but I think it just makes more sense that people are able to see the meetups as quickly as possible without the inconvenience of traffic and all that stuff. So that's why we kind of evolved to this newer name called HackBuddy. And again, it's software engineering focused. So we want to help people become better at their career. So if you ever have questions, you know, like things you want to learn, if you want to like get better at something, if you want to get a job, if you're having a hard time with the interview process, you know, just hit me up. Like, again, my LinkedIn's right here. I network with a lot of people. I want to just help people. That's my job in running this group. And like what I get out of it too is like I get more learning and fulfillment myself. I feel like I become a better engineer because, you know, like whatever questions that you have, I'm probably sure I'll have them too at some point in my own career. So I just want to be ahead of the game and all that. So that's the whole story there. If you want to follow the group, it is just HackBuddy. And so basically the easiest way to do that is just go and you know, go to the website, obviously, and then you can check out these URLs, but I'm going to show you the YouTube channel just because a lot of people ask about it. So the YouTube channel is youtube.com/hackbuddyorg. And then that's ORG, by the way. And then all of our videos, especially this one tonight, will get posted here. So you can rewatch the video, especially if you have that thought in your mind. Well, this is a cool presentation, but what did I just watch? I kind of need to go back and watch it again to digest it again. I get that sometimes stuff is confusing. So make sure you have this subscribed. And you can also tweet to us. You can also Facebook. You can also Instagram. If you like pair programming and you just want to get better at coding, you know, you want to be more active as opposed to just watching meetups and watching Udemy videos or YouTube videos or whatever, then come join our team, teamhack.org. I'm leading it. And my whole charge with this is just to, you know, practice a lot of the stuff that, you know, we've already got a lot of cool members, you know, in the group. So, you know, like you can work with at most 33 people, which is pretty cool. A lot of them are talented. Some of them are from, you know, like companies you might want to work for, like Facebook and so on. So that I'll let you kind of figure out as you join the group. There's some cool people and some secret people. So it makes it exciting to kind of work with this particular project. And yeah, like, you know, we're doing stuff kind of industry standard. We're using GitHub, we're doing pull requests, issues. So it's a good way to learn all that. Learn to use React, learn to use TypeScript, exactly what you're seeing in the meetup today. And that's the thing, that's the deal, right? Like we want to get better at this stuff. So that's why we have meetups about it. And so then we can do our work better, we can do our jobs better. And again, like whatever you need, right? Come talk to me, come network with me. I'll make sure that like I get like that information because this group is designed in a way to help find that, you know, like as far as networks and information. So we'll help you get better and we'll program together and we'll get good. So with that, thank you so much. If you have any questions, again, feel free to reach out to me in these different channels. You can reach out to me on Discord. This is like what we use to chat with everybody. And there's a link for that on the website. Again, the website is javascriptla.net. Here's the link for Discord. Here's the link for Slack. Here's the link for Team Hack. And oh, one more thing. Tonight, just make sure that you check your email. Don't block us or say, hey, stop, emailing me. It's like a small thing. I just want to make sure that people see that we have a poll. So click here to give us feedback and just let us know how we're doing. Because really, like if you enjoy these meetups, let us know. If you didn't enjoy something, let us know. The feedback you give us makes us better so that we can make you better. That's really the whole deal. So please be sure to fill out the poll tonight. And with that, let's go ahead and jump into the presentation. And I think you have the ability to share your screen. So let me know if you don't.
Awesome.
Josh.
Cool. Yep, we're good. And first off, thank you for that great introduction and set of information. It's an awesome little group. Sorry, an awesome group. It is not little, it is actually quite growing. So I'm really excited to be able to take part in this. Let me share screen. We have a presentation, part of my tweet deck. We have a presentation, which I posted in the Zoom chat. The presentation links to the GitHub repo, and the GitHub repo links to the presentation. So feel free to ask in the chat if you need a link and someone can give it to you.
Perfect.
I'm loving seeing these little admit notifications on the top of my screen. So let's start. Hello, everyone. This is Intro to TypeScript and React. It is for people who already know JavaScript and some React and would like to know TypeScript and how to use it with React. Very exciting. The agenda today is we're going to talk about some setup, just like basic prerequisites and how to use this presentation / workshop. We'll talk about what is TypeScript. Yay, TypeScript, some features of TypeScript, and then talking about how TypeScript works with React. It'll be first me, then Sylvana. So some ground rules, a little bit of intro for what's going on. Oops, sorry, my computer's lagging. First and foremost, no one remembers everything that they are told over whatever this is going to be, half hour, hour. So definitely don't worry about forgetting syntax, little things. You can always find the stuff later on, the recordings, the links. So it's totally fine to take a little while on the syntax, even the concepts. The concepts are the stuff that's important. And if you haven't yet, I'd recommend installing Git, some version of Node that's supported, and an editor such as VS Code, which is our personal recommendation. And the links are in the slide notes that are in the presentation that you can view online. And with that, you should be pretty much ready for this talk. Very exciting. I also just realized I'm using the online viewer, which is vastly inferior to the PowerPoint viewer. So there we go. Look at that better font. All right. About me. Hi, I'm Josh. I work at CodeAcademy as a front-end developer on our web platform team, which means I work on the shared tooling across a lot of our front-end apps, which involves Gamut, which is our open source design system, which we can give a whole other presentation about if you're interested. Build tooling, such as things that set up React and TypeScript, a lot of our shared utilities and standards, like how to write tests. I love meetups like this, groups, organizations that talk about things like React and TypeScript and open source. So this is kind of my fun stuff. Next up will be a slide about Sylvana. Take it away, Sylvana.
Hey everyone, yeah, I'm Sylvana. I'm also an engineer at CodeAcademy. I'm on a product team, so that means I get to use all of the fun stuff that Josh and the web platform team build for us. I've worked on various features like the dashboard revamp and weekly targets, and the most recent project that I worked on, which was really fun, was sandboxes, although now we're calling them workspaces, so don't call them sandboxes. But yeah, that's a little bit about me. You'll hear more from me later down the road.
Thanks. Cool. So let's talk about TypeScript. What's going on? What is it? Why do we care? You might have heard this phrase, TypeScript is a typed superset of JavaScript. And if you have heard that phrase, you might be asking, what does that mean? Why? It's kind of a buzz phrase. Let's start off with a little context, and then we'll go into why that phrase is awesome and beautiful. JavaScript was made in 1995. Famously, it took about 10 days for the initial design of it, and everyone has been poo-pooing it ever since because it has some quirks. For backwards compatibility, it can't be completely overhauled. We can't just make it like Python or C# or whatever your favorite language is. It has to remain the same with things built on top. So there are some fun parts of it that are a little suboptimal for building applications at scale. For example, let's say that you wanted to add the ability to have template strings, which are a nice little feature that newer languages have. You would be able to add that to JavaScript because the newer version of it, pardon me as I move the Zoom stuff out of my way, the newer version, which we see below, compiles down to the version that's older that we see on top. So we can add little features like that, but this stuff, which is called syntactic sugar, these little syntax features, don't address that JavaScript isn't typed. It doesn't have a way for you to declare in your code things are a particular type or is supposed to look like a certain way. You can do little comments or informal things, but there's no actual way to enforce that, which means that it can be really hard to modify JavaScript at scale. Refactoring, the art of changing a lot of stuff at once, is really hard if you have nothing that forces things to be correct, no way to inform you what is first, what is last, what is supposed to go where. So that's one of the big problems of JavaScript. Now, let's talk a little bit about TypeScript. If you want to get started, you can git clone this repo locally. Instructions are in its README. And again, it should be in the chat. Feel free to ask in the chat if you need the link still. TypeScript adds some things to JavaScript that I'm a big fan of. For starters, it's a superset of JavaScript that adds in an understanding of your types, meaning TypeScript reads in your JavaScript code and understands where you might have messed up. Technically, this is called a superset. It's all of JavaScript plus some stuff on top of it. One of the things that TypeScript does is it'll read your code and make sure that you've called functions with enough parameters. For example, if you were to write this function greetPerson that takes in 2 parameters and then only give it 1 argument, TypeScript would complain, hey, we expected 2, you forgot 1. And I'm going to quickly show you that repo locally in my VS Code. So here we have the repo, which I have git cloned and run npm install on locally. And per the README, I am going to go down and run tsc-w snippets1. Now, snippets1 is a file here, 1.ts, where we see the code example from the slides. And here we see 2 little complaints from TypeScript. TypeScript is complaining with the little red squiggly, think like Microsoft Word or Google Docs, red squiggly. It's complaining with this error message, expected 2 arguments but got 1, an argument for last was not provided. And also in my terminal, where I separately ran the TypeScript command, it's also complaining, giving me this nice little colored out. Thanks, TypeScript. It helped me realize that I have to fix this by calling with 2 arguments. And now that I've saved the file, the terminal is happy, and VS Code's TypeScript language service is happy. Cool. So TypeScript is really a couple of things. For starters, you can run it on the command line. You can use this little tsc command, which is the npm packages little runner, which runs it on some kind of terminal for you. Also, a lot of editors, such as VS Code, have an IntelliSense concept, which is running a language in the background and reporting its complaints to you. So it's kind of like Clippy, but with a better user experience and fewer weird paper clips. Which means TypeScript is pretty common, and it's quite easy to get someone or something to use it. All the major text editors have some kind of built-in support or a really popular extension for TypeScript. Just off the top of my head, Atom, Sublime, Emacs, Sublime. Oh, that's on there twice. Whoops. Vim, VS Code. All these things have or supports TypeScript really well. VS Code in particular uses TypeScript famously for JavaScript files to give you limited IntelliSense on JavaScript, which is kind of cool. And then one of the key innovations of TypeScript is that even though it is a superset of JavaScript, it compiles down to regular JavaScript, kind of like how Babel, if you used that before, goes down to JavaScript, which means all sorts of libraries and stuff use TypeScript or support it. Angular famously strongly recommends using TypeScript. Svelte and Vue have support. React has basically always worked with it. And then all these frameworks and full stack shenanigans like CRA and Gatsby.next have TypeScript support. So if there's one key takeaway from this talk, if you're looking for a job, is that TypeScript is everywhere, and it's an awesome thing to learn if you want a job. Because a lot of companies, CodeAcademy included, are actively hiring for people who know. Yay, TypeScript. All right. So let's talk a little bit about the TypeScript features. What does it know? How does it know those things? We'll find out together. From the very start, our second example is type inferences. TypeScript reads code and remembers the initial values. For example, my name is known to be a string. And I just realized we forgot to update this slide commands. This is snippets/2. You're watching me live edit this slide as we code. This is great. So let's look at snippets/2, the file. .ts. And relying on folks to answer or to mention questions to me in the chat. There is a great question that we can answer now. How easy is it to pick up TypeScript if you've been using JavaScript for about a year? I'd say that's a good time to start learning TypeScript. Sylvana indeed picked it up on the job. A lot of people join companies and end up learning it. All you really need to understand TypeScript is a good foundational knowledge of JavaScript, which should come at a few months. Wouldn't recommend it if you don't yet know JavaScript. Pardon me, it's quite late here. Anyway, snippets/2. tsc-w snippets/2. TypeScript looks at our code and sees that we have declared this my name variable. My name is of type string. If you hover over it, it says my name : string. TypeScript understands that because there's an initial value on the variable. Later on, when we use the variable, TypeScript can tell us if we've used it correctly or incorrectly. Taking a look at this first example, TypeScript sees my name.len is wrong because my name is of type string, and string does not have a len property. It does have length, but not len. So if we do use length instead of, let's say, some wrong thing len, TypeScript knows that it exists, but it's type number, which doesn't have any call signatures, meaning it's not a function. So TypeScript can look at our code and tell us if we use something the wrong way, and it'll shut up if we use it the right way. You can see in my little output down below, we have two issues on the terminal. I'm going to quit the terminal just to show that the terminal is irrelevant. If we comment out the issues, we no longer have red squigglies in code. And if we rerun the terminal, it'll update in real time as we fix these issues. Come on, TypeScript. There we go. And again, please make noise in the chat if any of this stuff is unclear or if you have questions. Always good for me to be able to answer things now and not later. Cool. So TypeScript can infer from your types, infer from your values what stuff is supposed to look like and let you know if you've done it wrong. Sometimes it needs a little help. In this code snippet, better name is a variable that doesn't initially have a value, let's say string, which means that TypeScript won't know what the variable is supposed to be typed. In this case, you can add a little colon space as the type to tell TypeScript what type that variable is supposed to be. Again, correcting my slide here in real time, like an adult and professional. And let's look at snippets/3. Cool. Snippets/3. So if a variable doesn't have an initial type, you can give it the little colon space to tell it what's supposed to be. And then the variable is considered to be that type. So just as before, if you use it wrong, in this case, let's say you give it the wrong type of value, TypeScript knows it's supposed to be, let's say, a string. And this works too for function parameters. In this case, input doesn't have an initial type, so we declare that it's supposed to be Boolean. Ultimately, we could have said something like equals false, which would have then told us it's still a Boolean. Later on, TypeScript knows that if we call this function, we need to have the right parameter argument type match for that function. Thanks, TypeScript. Cool. So in summary, type annotations are a way of telling TypeScript what type something is supposed to be if it doesn't have an initial value. Type unions are a really cool concept. I think this is one of my favorite things in type systems and the theory and all this. Sometimes a variable can be one of two or more types. In this case, let's say they have a function that takes in a parameter that could be a string or it could be undefined. Maybe it's optional, maybe it's just sometimes undefined. TypeScript can then infer from your usage a more narrow type understanding of that. And let's look at this in code. Oops, spoiler. Let's look at this in code. Snippets/4. So 4.ts. There we go. In this case, name maybe is a string or undefined. Another way of saying that, which is almost the same, is saying name maybe is an optional string, which means it doesn't necessarily have to be provided. Oh yes, the slides are linked in the README of the repository, and thank you, Spawn, for posting in the chat. Why is ESLint complaining? That's quick fix, disable ESLint for the file. There we go. So in this case, takes name maybe, takes in a parameter which is a string, but it could be undefined. So if we try to access a member of it, TypeScript tells us, no, that's wrong. It could be undefined. Name maybe might crash. However, if we do an if statement that narrows it down, meaning inside of the if statement, TypeScript understands name maybe must be defined, then TypeScript can tell you, okay, this is okay. We know name maybe is definitely a string. And that works well if you have a parameter that's, let's say, a number or a string. It's not just these undefined checks. Where inside an if statement, if you narrow down that this variable must be, let's say, of type number, then we know that it has all the methods and properties of a number. In this case, either is a number, so toFixed is allowed. And if it's not a number, and originally was either number or string, by process of elimination, we know that it's a string. Cool. And then outside of this for loop, we can't do things that only exist on number or only exist on string, because we know it's either a number or string. Those things might not exist on the parameter. This is a really powerful concept, this type narrowing situation. It's using a lot of really advanced features that we won't go into, but I think it's a really cool example of how a very flexible, fluid, what's called structurally typed system like TypeScript has some really interesting advantages over more traditional languages like C++ or Java, where they don't really have a concept of narrowing or type unions. You can't have something in Java that's either a number or a string. It has to be one or the other for the most part. It's kind of cool. Thanks, TypeScript. All right. From now on, it's going to be a few random miscellaneous features that are useful. For example, function types. Let's say that you have something that's supposed to be a function. The function type looks kind of like an arrow lambda, or what formerly people used to often call fat arrow lambdas, but without the body. It's parentheses, the list of parameters, right parentheses, arrow, the return type. So in this code snippet, we say that we have a process variable, which is a function type. Cool beans. And again, my computer's lagging. Apologies for the slides spoilers. So let's look at 5.ts. Here we have a variable process. Oh boy. My IntelliSense is going wild today. Here we go. So this process is of type function that takes in a string and returns a number. So here we can infer from the type declaration on process that in this function, input is type string, because we have already said that process is a function that takes in a string. Later on, if we try to assign process to a value that returns something that's not a number, let's say I don't know, a string or a Boolean or something like that, TypeScript will yell at us and tell us, no, that's not allowed. Let's say Boolean is not a number. Yay. And then later on, this thing is fun. If you mess up the arguments, let's say you pass in a number explicitly, like you've declared it, then TypeScript knows, no, it's not a number, it's supposed to be a string. And this works in a surprising number of places. Let's suppose you have an array of objects in JavaScript. Let's just comment out this whole thing. Const my names equals Josh Sylvana, whatever. And then you do my names stuff for each name console.log pi name. TypeScript can infer that my name is an array containing strings. The syntax for which looks like this. And then in for each, the array for each takes in a function, which is of type value, whatever's on the array, in this case, string. So TypeScript knows that name is a string because the types flow through nicely. And that means that if we were to use this, say, with something that doesn't exist on a string, like the toFixed method, TypeScript would yell at us. Thanks, TypeScript. Cool beans. Back to the slides. Now, the most advanced fancy stuff that I'm going to talk about with you are objects and interfaces. JavaScript has all sorts of fancy object types in it. You can make new objects willy-nilly, like in this case, the SpongeBob variable, assign them all sorts of members, which can be functions or values or other objects or whatever. So TypeScript has to be able to represent those in order to let you use real JavaScript. Now, TypeScript allows you to describe how objects are supposed to look with a construct called an interface, which is somewhat similar to interfaces in other languages if you use them, but not quite the same. And I want to give you some vocabulary here because I think they're cool and important to know. TypeScript is structurally typed, meaning anything that seems like it should work in the type system will work, which is different from JavaScript's duck typing, and I'll go a little bit into why it's different. JavaScript duck typing is a runtime system where if an object has a member that you ask for, if it works, YOLO, it's fine. If it looks like a duck, it quacks like a duck. Then it's probably a duck. That's the duck typing method. In TypeScript, there's this kind of coincidental, oh, if it happens to work, it works in the type system, not the runtime. I will show you in the snippets file what I mean by that. I guess we can save 5.ts. See w snippets 5. No, 6.ts. There we go. Let's say that we have this interface person. In this interface, we have declared that when I say person, I mean something that has at least these two things: a greet method, which returns nothing or void, and a name string. So this SpongeBob is allowed to be a person because it has a greet and a name. Good. Later on in TypeScript, if I declare that, let's say a parameter is of type person, that means in TypeScript, we know that it has a name and a greet. And in TypeScript's land, we see that if we hover over person.name, TypeScript can tell us via VS Codes and tell us sense that it's a string. Or if we call greet, we know that it's a method that returns nothing, aka void. If we were to try to pass something in here, like a number or a string, whatever, TypeScript would yell at us saying, expected no arguments, but got 2 instead. Thanks, TypeScript. Now, in most languages that have types in them, statically typed languages, if something is declared to be an interface, it's allowed to be passed into anything that requires an instance of that interface. But the key difference with structural typing is that if something coincidentally seems to match the type, it's still allowed. In this case, let's look at Patrick. Patrick does not explicitly say that he's a person. You follow the lore of SpongeBob, you would know that it's because Patrick's an idiot. If you don't, that's okay. But you should watch SpongeBob. Now, Patrick just so happens to have a method greet and a name Patrick. And even though Patrick's not explicitly declared to be an interface, structurally, he matches up with the type. So it's allowed. He can be passed into log person. But if an imposter comes along, let's say Plankton, who doesn't have a greet, he has an announce, then Plankton, I'm just going to move this interface down so we can see it all on the screen. Plankton will cause an error because TypeScript knows that the person is supposed to have greet and name, and Plankton has announce instead of greet. He is missing his greet. Therefore, Plankton's structure does not match this person structure, and he is not allowed to be passed into log person. I will repeat because I love this stuff, and I think it's cool and useful. Structural typing, what TypeScript has, is when you declare how things are supposed to look in the type system using stuff such as interfaces, and anything that happens to match up is allowed, and anything that doesn't happen to match up is not allowed. Cool beans. Fun fact, interfaces can get super complex. We could have like a fancy name on there. So like maybe fancy name has first string, last string, and then fancy name has a fancy name. So you can get nested interfaces, but the only way to match person would have a fancy name, which is first, last, whatever. They can get nested, they can get infinitely sized, all sorts of stuff. But for now, let's just keep it to person. Cool. Plankton is the imposter. That's about all I have for TypeScript and React. I can pause for questions here. Sorry, all I have for just TypeScript without React. And then pass it over to Sylvana if no one has any questions in the chat. Cool. Take it away, Sylvana.
All right. I guess you guys will have to deal with the inferior web form of PowerPoint because I don't have it on my laptop. So apologies, I didn't know it was inferior. Cool. Let me set up my Zoom here so that I can actually see the chat and hopefully catch any questions. Bear with me. All right, seeing the chat now. Cool. So now that Josh has gone over the basics of TypeScript, we're going to take a look at TypeScript with React. And the repo that I will be using during this portion is also in that same repo that was shared earlier. Cool. So to begin, let's take a look at what React looks like in pure JavaScript. So here we have a functional component. It's a card similar to what you might see on our website at CodeAcademy. It takes in 2 props, or we expect it to take in 2 props, the first of which is course type. And we would expect that it's just a string that gets displayed on this p tag down here. And then the second input, or the second prop, is show pro label, which we would expect to be a Boolean, and it determines whether or not we display this pro label on our card. Cool. So if you wanted to use this component, we might do something like this. We'd call the card component and we'd send down the props. For course type, we might send down a string like career path. And then for show pro label, we would send a Boolean, in this case, true. And if we did that, we'd get something that looks like this. Not as beautiful as it looks on our website, but it works. So what's the problem with this, or what are the limitations of this? Well, in a nutshell, it's just easy to make mistakes because essentially you can pass anything you want to this prop with little to no feedback that what you're doing doesn't necessarily make sense. So examples of this is that you can send down a prop that the component doesn't expect. So for example, here, I'm sending down a prop called difficulty, which doesn't exist on the card component. It's not expecting that. Another thing that you could do is to miss a prop that the child expects, right? It's expecting a prop called course type, but maybe I don't pass that down. Another thing is that you could send down unexpected values. So for example, here for course type, I'm sending down a string that says roller coaster. Now, technically this isn't wrong, but conceptually it doesn't make sense, right? Like a course type or roller coaster is not a course type, arguably, although some may feel like roller coasters. And then another thing that you can do is that you might mistype a prop, right? Like it's really easy when you're coding that maybe you miss the Y on course type, right? And then the last thing is that you could send down the wrong type. You can see here that for show pro label, instead of sending a Boolean down, I'm sending down a string that says yes, right? So these are common things that you might run into, but like I said, some of these will just silently error, or you won't know that you're doing something wrong until you actually build and run the application, right? So TypeScript can help us with that. Now, I'm not going to run through how you actually add TypeScript to a React project. But I did link the docs there that walk you through it. I do want to point out one thing though. You'll see here, if you're trying to add TypeScript to an existing, also, are you guys seeing the docs right now? I can't remember what I shared. Okay, cool. Thanks, Josh. Yeah, so when you're adding TypeScript to a React app that was originally in JavaScript, it'll ask you to install all of these libraries. The first of which is TypeScript, which makes sense, right? We want to install that library. But then you'll see we have these other ones like @types/React. And the reason that you have to install these other libraries is that when a library is written in JavaScript, you'll have to also install the library @types/ whatever the name of that module is. And that'll that module defines the types used by that library. And we'll see an example of this in just a bit. But just wanted to point that out, so keep that in mind. Cool. So once we have TypeScript added to our projects, we can start doing something like this, which incorporates some of the concepts that Josh went over. So you can see here that I am defining an interface called card props. And essentially what I'm doing is I'm saying that the props should follow this structure, right? So it should have a property called course type, which should be a string. And then it should have another property called show pro label, which should be a Boolean. And then down here, the syntax might look a little intimidating, but it's not as scary as it initially seems. Essentially what we're saying here is that card is a React functional component. And so what that means is that it is a function that returns a React node. And then the second part here is just saying that this function is going to take in an object that looks like this card props interface up here. So those are the basics of what a component will look like in TypeScript. So if you have any questions, now would be a good time to drop it in the chat because we're gonna add to this and get a little more complex from here. Let's see, is there a way to make project with TypeScript? Yes, that's in the doc that I shared. There's a way, there's like a template where it'll automatically add it from the get-go. Good question. Cool. What advantage does it have over prop types? Yeah, we actually use types at CodeAcademy. Josh, I am too far gone at this point in the day to remember everything you told me. You will have a better answer for this about why we use interface over types, or we should.
I'm actually interpreting the question as why do we use it over prop dash types, like the package in JavaScript that lets you say like component name dot prop types equal. Should I answer?
Yeah,
that
those
too?
are React prop types, just giving you some context. I think that's what you're asking, right, Yulia? Why do we use this over React prop types? Okay, yeah.
Cool, yeah.
So, yeah, do you want to take this, Josh, or I guess?
Sure, yeah. Great question. React prop types does have an advantage that it's in pure JavaScript. You don't have to add TypeScript and add type slash whatever for it. But unfortunately, it does add to the complexity and bloat of your JavaScript, and it's not as precise as TypeScript. The first problem goes away with a lot of build tool chains that remove it for production code, but the second doesn't. It doesn't have nearly as many precise ways to describe, say, nested object shapes as TypeScript does. And there aren't any mainstream compilers I know that'll like block a build over it failing. It's more of a runtime check. So like if you say that like your component has prop types of some shape, there's no tool that will tell you in your development editor, in your, say, VS Code window, whether you're adding the right ones. And its syntax is quite a bit more limited. Like in TypeScript, you can represent unions of interfaces or like really complex shapes, and prop types just doesn't have the ability to do those. There are a few other downsides, but like those are the big ones.
It's a great explanation.
Thanks, Josh. Cool. So if there are no further questions, oh wait, is there something in the chat? Oh, thank you. Cool. All right. So once we start adding these types to our components, we'll start getting some really useful TypeScript errors. So I'm actually going to go ahead and jump into code to take a look at some of those. So also just FYI, if you're following along, if you git clone the repo and then from the root, just do yarn install or npm install and then yarn start, you can run this app. But let's go ahead and get started. So right now, as I showed on the slides, I have the props defined here and react.fc with the props being taken into that function. And if I go over here, you can see that this will give us some errors. So for example, if I go here and try to give this a string instead, click save, you can see that down here, I get a useful message telling me that string is not assignable to the type Boolean, right? Show pro label is expecting a Boolean, but I'm giving it a string. Cool. Let me go back. Another cool thing that you can do, or another way that we can use TypeScript that might be pretty common, is let's say, for example, that we want to add a click handler here. So if we wanted to make this div clickable, we might do something like this. Okay. And we would define that by using the syntax that Josh talked about earlier, right? We're saying click handler is a function that takes in no parameters and returns void, right? And so then if we go here, we can do something like this, click handler. And the nice thing is that now it actually gives a suggestion that this is a prop that this component will take in. So it kind of helps you develop a little bit faster as well. And for now, oh, that went away. I had a function there, but let's just say we give it an empty function that doesn't do anything at the moment. Let's see. Cannot find click handler. Did I not? Did I spell something wrong? That's a bummer.
Might be missing the prop itself from props.
Oh, you're right. Thank you. This is why I never live demo. I run into problems like this.
This is great.
Yeah, I have to deconstruct it there. Thank you. Yeah, let me deconstruct and that should be good to go. Cool. So now it's compiled successfully. So you can, like, here, if you wanted to console log something or make it redirect to another page, we can do that with TypeScript. Cool. Let me jump back to the slides. Another cool thing that you can do is use optional props. So for example, let's say we come over here and we want to add to our card. We want to be able to add sort of like a label to our card to indicate that this course, let's say, the content has to do with job essentials or language fluency, right? We want to add a tag to describe that course. So we'll add another property for our card component called tag, and it should be a string. And then let me just go ahead and uncomment this. Cool. So now you can see that I'm getting an error down here, and it's telling me that tag is missing over here, right? So I could give it a tag over here. Let's just say, for now, blah. Not a great tag, but you know. Oh, once again, forgetting to deconstruct here. All right, cool. So now we've compiled successfully, and if we go, I realized I didn't show you guys the lovely component running over here. Cool, we see something like this, right? And our tag is down here below. But maybe not all courses can be given a tag, right? There's some that can't be narrowly defined or narrowly described. So we might have some cards that we don't want to show the tag on. But right now, if I were to remove this property, I'd get an error as we saw before, right? So how can we get around this? There's two options that we have. One is that we can use a union, what Josh introduced earlier, right? We can say that this tag can be either a string or it can be undefined. So let's go ahead and try that over here. So if I do string or undefined, let's save. Let's see, tag is missing. Oh, why? Oh, is it just not updating? Why is it not showing it in the tab? Let me try restarting. I don't know why it's not registering that I added that to the table.
Sylvana, you will need to add the question mark there. Fun fact.
Fun fact. Oh no. Okay. Well, that doesn't work. This is all part of the demo. I've fooled you. So another option that we have, as Josh alluded to, is that we can add a question mark here. And that basically indicates to TypeScript that this parameter is optional. So let's go ahead and try that. Like this, and add the question mark here. Now it's compiled successfully. And if I go back to here, let's restart this. Now you can see that the tag isn't showing, which is not great UI. There's still like a little blurb there, but it's working. It's compiling. Cool. And I've added a link here to the docs that describe a little bit more about optional parameters there. Cool. Another thing that we kind of alluded to here is that you can use unions in your React applications. And a good application of this, we can see with course type. So if we went over right here to the code right now, and I did something like made the course type roller coaster, I wouldn't get any errors, right? Because this is technically fine according to what the props that I defined. But as we mentioned earlier, conceptually, this doesn't really make sense, right? So how do we enforce that? Well, we can enforce it using something called string literal types and unions. So you can see here with this syntax here, what we're saying is that course type can be a string that says course, or a string that says career path, or a string that says skill path. And so this will enforce sort of the paradigm that makes sense conceptually. So if I go back over here, let's update this. For now, I'm just going to say this can either be a course or a path. And go ahead and save that. And now you can see down here that it's saying type roller coaster is not assignable to type, right? Because it doesn't match either of these strings. But if I go here, update this, and let's just say this is a course, save that. Now it's compiling successfully. Awesome. So one last thing that I wanted to make you guys aware of is sharing props, which I think is super useful when you're building really complex UIs. So what you can do, let's say that we wanted to break up our card component and create a section that was the header, right? And that header just contained our pro label and the course type. So we might create a separate header component that takes in those two props. And we would define that. Oh, I forgot to update this to interface, but these should be interfaces. So let's say we export that interface in our card header file. And then I import it in the card component file. And then what I could do is that instead of rewriting, right, show pro label and course type in the props for the card component, I can actually use this syntax here and it will sort of merge those together. So now card props would be show pro label, course type, course name, click handler, and tag. It would encompass all of those properties, right? So this is really neat when you're breaking down more complex component into smaller ones. You don't have to be rewriting the same thing over and over. This is definitely something that I use pretty regularly. But yeah, that is all we have for you today. I'll open the floor to questions, and let me make sure that I didn't miss anything. Can you talk about types as well and how it compares to interface? Josh?
This was the question we were thinking of answering before.
Yeah.
There are two ways to declare in TypeScript that when you say a particular name, you mean a list of object members or functions properties. One is type, one is interface. They are almost the same in usage, but have some very key differences. Would it be okay, Sylvana, if I shared my screen and showed syntax? Cool, thank you. I'll just rudely steal yours. Cool. I'm actually going to use this tool, I was looking up TypeScript versus prop types, to show off the TypeScript Playground, which is a really nifty website that lets you play around with TypeScript in the browser. So yeah, you could say interface has age, which has an age number, or you could say type has age equals age number. These two are roughly the same thing. Like these both work the same. In general, there isn't really a great signal standard for them. The TypeScript community is kind of split. I've been starting to prefer using interface over type. The key thing with interfaces is that they have a few like nice ergonomic things, meaning it's a little easier to use them in some cases. For example, if you have a class like my person, you can say that a class implements an interface, which means that like if you mess up, if you don't have one of the members of the interface in the class, TypeScript will yell at you. We forgot to add this name declaration. So let me quick fix that in. Beautiful. Age, let's just make it always equal 0 by default. Side note, you can see the compiled JavaScript on the right. Yay, TypeScript. Another nice little advantage for interface is that if it's declared multiple times, they all magically move together. So like has age and has age make it so that any has age implementer must have both of these things. So like, let's say is happy is false. Whereas for types, if you were to try to do the same thing, it would yell at you that they can't be declared multiple times. We have duplicate identifiers. Under the hood, interfaces are TypeScript's way of saying, I have this new thing in the type system, whereas types are a way of saying, I have like an alias for a thing. So an alias means that it's a little less performant on the inside. You're recreating instances of that object in the type system. If that doesn't make sense to you, that's totally fine. I don't know a good way of explaining that, and I'm sorry. But the advantage of types is that you can do fancy things like name or number equals string number. You can't do these union types with interfaces. That's just not possible. So the annoying thing about them is that there's some things that are only doable with interfaces and some things that are only doable with types. So sorry, that's such a long explanation, but that's the one I got. Does that answer the question you were going for?
Yeah, and actually, this is great because I was kind of looking up some documentation for styled components the other day with TypeScript, and I think like just what I had seen. I guess I can bring it up. Here, I'll kind of share my screen as well. Just something that Team Hack is interested in. We're kind of converting our code base from regular JavaScript to TypeScript. And so kind of like looking over some of the things that you guys talked about today. We have the interface, then we have a declare, which I think exports the interface. And these are the props that we need. But then you also have type. And I think I saw it either in this example or the other example. But like what you just showed with the union, that was possible through here. And so that's something that they're using as a pattern in styled components with TypeScript. So let me see if I can send this over to myself from my other computer. If not, then I'll just basically say that it was the one thing that I was kind of thinking about in the back of my mind, because we are architecting this ourselves. So yeah, it's good to see that. So let me just grab it here, actually. And good old Dan, thank you for that. So yeah, here we go. And yes, you have your declaration file, and then you have type of theme. Theme comes from here. So I think that's what you were kind of referring to. You can't do that with the interface. Is that correct?
Yeah. Funny, I've seen instances of this in our own shared library code. I wonder if the person on our team who implemented our shared libraries was reading the same blog post. Yeah. In this code, type theme equals type of thing. Type of is like an operator in the type system that says, I want whatever type that thing is. So yeah.
Exactly.
You can see that type theme equals type of theme, and then export interface default theme extends theme is kind of how you do that with an interface. And the reason I suspect they're doing it that way is because type aliases allow you to grab something with these like more clever controls, like an equals, but then an interface kind of caches it in the type system for performance. So you get like better performance and better error messages if you mess up.
Exactly. Like, and I think like, the thing about TypeScript is, once you start using it, you definitely see the value. Like, I think like initially when you start reading a lot of code that is in TypeScript, it's a little overwhelming sometimes. Like, it's like, if you don't remember that this is a function itself, and then this takes in like a prop, like that gets hairy to read. Same thing like down here. So what would you say, like, as far as just like getting better at reading TypeScript. Like, do you like have any methodology of like understanding this faster or like reading it faster?
I'll answer and then I'll pass it over to Sylvana.
Sure.
I try to, I mean, part of it is like repetition, like with any language. If you keep reading the error messages, you keep messing it up, eventually you'll know the common patterns, which is a very painful truth for everyone. I also particularly think it's good to practice reading those like big call stacks, like the pyramid of death or doom error message TypeScript sometimes gives. Sometimes TypeScript can give really unfortunately big error messages. But the reason why they're really big is because it'll give you the big interface that you messed up and then narrow down each part of the thing that's wrong until it tells you the exact field. So being able to take a look at the top to know the big thing that's wrong, and then the very specific bottom to know the exact place, looking at those two things first can give you kind of like a good starting point. But Sylvana, do you have any pro tips as someone who learned it over the last year for work, year or two?
Advice for learning TypeScript? So wait, sorry, which question are we answering?
Sure.
Yeah, just feeling more fluid, more like fluent with it, I would say. Like, I think like sometimes, like, guess the main question is it can get hairy to read TypeScript, especially if, like you're kind of reading tutorials or, just checking stuff online. Here I'm on the React TypeScript cheat sheet, which I think I found the other day. But yeah, like when I first read this, I was like, what is that? Like, I mean, I'd never seen type before. I had seen interface. And so that just confused me for a little bit. So I guess like now after this presentation, yeah, like I definitely have a better sense, but yeah, go ahead.
Yeah, no, it's definitely, I think I was writing like a summary of a talk that I wanted to give at another conference too. And one of the things that I said is that like looking at a TypeScript file for the first time is very overwhelming when you only know JavaScript. I would say like, I mean, this is very vague, but just like take it one step at a time. Like I remember one of the first things that I tried to look at was like a Redux like saga in TypeScript and like looking at Redux, like definitely don't start there. I think like starting with one thing, like I think React components are actually a great way to start getting used to the syntax. Like for example, the react.fc with like, the greater than and less than sign with the props in the middle, like even just looking at that was really overwhelming at first, but the more you start to see it, it becomes less scary. But yeah, just try to like focus on one area of code at first and like get the syntax down for that. And definitely try to like, I think starting to write like a component from scratch, for example, or trying to convert like an old component that's in JavaScript to TypeScript, like those types of exercises are really helpful to get you into the groove of things.
Yeah, definitely. Yeah, like when you told me about Redux with TypeScript, I remember last year, I was just trying to like understand Redux a little bit better. And I guess like somehow I kind of landed on this page and I was just like, I don't even know what Redux is. And like, here's interfaces on TypeScript. And I'm just like, how do I read this? So, I mean, like I kind of got my way around it, but yeah, initially like all this stuff too, like kind of just made me like, what is going on here? You've got the generic type, which I think I get from, like my days of Java, but like, it's still, it'd be good, just kind of like some insight into this. And, if you're like, oh, well, you want to take a bigger look at this, that's totally fine. We can always, have you kind of share your thoughts afterwards too, like on Discord or, like a potential sequel to this meetup, if you ever want to do that.
Yeah. Another piece of advice I would give too is like, if possible, pair on someone who's knowledgeable on TypeScript a lot, as much as you can. It's really hard to like break down the syntax on your own. I find it a lot easier to digest when someone talks through it and like I can pause them and be like, okay, what is this part here doing? And then like once I understand that part, I'm like, okay, what about this bigger part? Like, it definitely helps.
Yeah, for sure. Josh, do you have any other insight? I guess we are missing people's questions too. Like we can come back to that as well. So, okay, let me actually ask you the questions because I don't want to ignore anybody. So let's see here. First, Joey asked, is defining an interface comparable to defining a struct? And I think he's talking about iOS. And so he said very similar. I think you got the question here. Can you talk about how TypeScript uses semantics with functions or function types? And I think, Josh, you got that question, or did you?
I'm hot potatoing it over to Sylvana as I've talked a lot.
Okay.
Yeah, I was, I'm not sure that I understand the question, like just how TypeScript reacts when writing out functions. Is that the question?
Let's see here. So Lewis says, here's a link example. So Lewis, if you're there, do you think you can unmute yourself and ask the question directly? If not, then we'll just try to figure it out over chat.
Hi there, can you hear me? Okay, I'm here. I guess I was thinking about just because JavaScript is a, it's a functions as first class language. I was kind of wondering, is there any semantics inside TypeScript that address, I guess, anything within functions, I guess, just because it's such an important part of the language, that's all.
So just to be clear, like when you're saying anything about TypeScript that introduces function types, are you thinking like, like does TypeScript check that this is actually a function when you use it down below? Like does it check function properties, function methods that you might get from a function constructor? Is that kind of like what you're thinking?
Yeah, I was just thinking just overall, how does TypeScript work with functions just as a whole? Because I got a query question earlier this week, and it sort of took the form of, say, let me go ahead and type this in. So like I had one here. Add one. Let me see if I can actually do this. So
For sure.
okay, so I had a query question that had something similar to what you see in the chat, where I had an add function, and then I had actually I had one add function, and then I had to pass it variables in two different ways and get the same answer. And there was some understanding of closure within that question. And so right now I'm thinking, is there anything within TypeScript that can help me out just in terms of the types and to be able to sort of address that sort of question? And so it was kind of like it's an interview question, if anything, but I thought it was really interesting. And so I wanted to come on to just see if I can learn a little bit about TypeScript, and maybe if it's an area that it can help me with. It's just something I was really wondering about.
Yeah. I think like I'll kind of talk about this first, like just so I give some context, and then I'll pass it to you, Josh, because I think it'll help. Like if you also have some insight, and Sylvana, of course. But yeah, currying is just basically the idea, like converting one function with one set of parameters to being able to like call it with other parameters. So like here's an example of a curry. Currying function. So you're taking the target function, passing the first set of args, and then returning a new function with those args, and then doing some kind of logic here before you return the new function. So like currying, you're kind of like mishmashing functions together. That's kind of like the idea. And then TypeScript, I guess you can use some of these types here, I guess, to kind of check or help error check. But I'll send this to you in the chat as far as something you could take a look at. Josh, Sylvana, do you want to kind of just give like a high level overview of like maybe currying and TypeScript? And this could be something we can look at later too as a group.
Sylvana, I know I hot potatoed it to you already, but I'm actually really excited about this question. Is it okay if I answer? Cool. So every programming language has three areas. There's the foundational stuff, what one would mistakenly often call beginner. There's the intermediate stuff, and then there's the fancy stuff, which is often called advanced, but I don't like the connotations of that being hard. So I'm going to share screen because I love this. We're getting into the fancy things here. We'll start with the intermediate and then get into advanced. So like the very basic way to define a function is actually already in the talk, and we will build on it. I'm not just telling you to read the thing, but like let's say you have a function that takes callback, and the callback takes in an input of type number and then returns a string, something like that. So like const result equals callback 0, const.log results, fine, whatever. So like takes callback would then take in a function, what we know is type input to string. So then like, let's say that like the input is a number, and then we say like the result is my number is input. This would be like a very basic used function in TypeScript. So what you're asking is, can we do advanced operations in TypeScript on our inputs? Can we, for example, let's say maybe we'll return, instead of like console logging the result of the callback, maybe we'll return a function that like takes in an input and then calls callback on input times 2, where input is type number. And then here, if we like takes callback on 2, I think the result should be, oops, const curried callback, and then curried callback takes in a number, and then this result would be, see if this works. I never used this logs part of the playground. Curried callback 2. Does that log anything? No? Fine, whatever. I'll just take the compiled JavaScript and run it in the browser DevTools. Haha. Oop. My number is 4. Yay! That worked like live demo I thought it would, which is such a rare thing for live demos. Yay. Cool. So this is very basic function types, like the foundational stuff. Something is a bunch of inputs, in this case one of them, and an output type. But TypeScript lets us do cool things in the type system. For example, let's say you have a variable, my results, that's supposed to be the return type. Oh my God, what's happening there? Return type of the type of takes callback. So this works. TypeScript allows you to use this type of operator in the type system, which says it's whatever the type of a thing is. And then return type is a type that takes in a type, and if the type is a function, gives back the return type of the function. So in this case, my result is a function that takes in an input number and returns a string. A slightly easier, so let's call this my courier. I don't know if that's how you spell it. Then my result is the return type of curried callback. In this case, the my result is going to be of type string, because curried callback returns string. And this is all possible because the TypeScript type system, moving into the fancy types, allows you to have logic in the type system, which is something that I would never, ever go into depth on with an introductory thing, because I feel like it's kind of confusing, and most of the time you would basically never need to use it. But there are some built-in types in TypeScript that on the surface work and on the inside use fancy logic in the type system, such as the return type. One last thing is that you can use a parameters type to take in a function and get the type of its parameters. Actually, two last things. So let's say it imports as parameters of type of callback, where callback takes in, let's say, a number, first number, second string, third Boolean. And that's whatever. Let's just say we like console log the inputs. Whoop. Cool beans. So curried callback here should take in a number, a string, and a Boolean. Cool. And let's log that. Actually, this returns nothing, void, so we can just call curried callback. So in this case, in the type system, I don't want to have to manually redeclare the parameters of this function here. So like the function takes in these three things, and I just say whatever the heck this function takes in, those are my inputs for this resultant curried function. So yay, currying in the type system. And then my courier is indeed the type that we expect, takes in those three args and returns nothing. So that's kind of cool. One last cool thing, sorry if I've lost you already, I realize this is like wacky and almost never used stuff, is with
It's freaking amazing. Good job.
I love this stuff. This is like my bread and butter. Generic, which we did not cover. Generic is a function or class or something can have, in general, a type that's specific to the usage of it. So like this function can have a generic like my callback, and then the callback is of that type. So like each time you call the function, the my callback might be different. You can think of generics like arrays. Sometimes an array has strings, sometimes it has numbers. I see there are messages in the chat. I will open it. My chat is lagging.
Yeah, they're all just saying great work, amazing.
Cool, thanks.
Yeah.
So in this case, we have a generic and the callback is type my callback, but this could be called like a number. Like there's nothing saying what my callback is. So in TypeScript, you can say that it extends function, or actually it extends args any, so anything, any, and cool. Now we're saying that no matter what the heck callback is, my resultant function is the same type as that callback. So like in here, we could say that like input is a number, but like first is a number. And then like second is a string. And then it really doesn't matter what we do with the result here. Let's just say like console log first, second. So here, booyah, TypeScript has an error, which it's good. We want TypeScript to have an error because we know that curried callback is whatever the heck the original type is and returns void. So here, inputs is first number, second string, because it's the parameters of whatever type callback is, which we have defined in the usage here for takes callback. And we can see the generic and the little hover has been filled in with first number, second string. Cool, it all flows through, it curries through. And lastly, we get this error because there's no Boolean. We expected only 2 arguments. So I think this is probably what the person who was interviewing you, I'm guessing, was asking for. Maybe like this is oftentimes if someone's checking for advanced TypeScript, this is the dumb stuff that they're looking for, which I question of the validity of an interview, but you know, what do I know? I'm just writing a book. That's all.
It's amazing. Amazing. Good job. Good job. Yeah. Perfect. Perfect. Let's see here. And I think like you're sending, I guess people are saying chat stuff here. You're sending some links about TypeScript. Oh, you sent is this the playground that you just did? Okay, awesome. I'm going to actually share this playground with our group later on. It's really cool. Yeah, I think like at this point, do we have any other questions? I guess like one last thing, just because you were so awesome with this, right? I'm not going to put you on the spot again, but I just would like your thoughts. Do you have any thoughts on like reading typed files? Like sometimes, let's say you're working with a library, it's in TypeScript, you go and look at the definition for it, and it gets kind of like hairy reading those definition files. Do you have any just kind of like thoughts on like, what do you usually do there, like to kind of look at some of that documentation or understand it better? Let me see if I can get you an example of that too.
You mean like other than crying? Because that's like,
yeah, other than crying. Yeah.
First step.
I guess like maybe what I wanted to ask, like, you know, in the back of my mind too, is like, all right, so you said that like TypeScript interviews sometimes like shouldn't ask those kind of questions. But I feel like if you are kind of interviewing for a TypeScript job, you might need to know like some of the more hairier, nittier, grittier stuff that you kind of like demoed here. So I would just say like, maybe it is important. Do you think like maybe reading like a lot of these like definition files, like let's say you're working with, you know, some library and like, let's say you just start a new project, you know, it's in TypeScript, you know, like, are you going to sit there and like try to figure out like, you know, the types, you know, if you have any questions or any of that stuff, or is that where you would normally kind of like, what's your thought process with like taking on a new library and like you discover some TypeScript, what are you doing first? You know?
No, that is a good question. I'm being a little overly facetious. It is reasonable that if someone has a TypeScript job, they should interview you and see if you have advanced TypeScript knowledge. That's fine. I don't mean to imply that this stuff is useless. It is quite useful.
Yeah.
Yeah, sometimes just by the nature of how wildly flexible some JavaScript libraries are, there need to be really complex type definitions to back them. Like we were talking about Redux earlier, and Sylvana astutely observed that Redux Saga is a horrible place to learn TypeScript because it's really complex like that. You're diving into the deep end.
Yeah,
so I would
exactly.
say sometimes you can get away without it. like instead of reading the definition files for TypeScript capable library, maybe you can read their regular docs instead until you're like super duper familiar with TypeScript. Personally, if I were to just read the DTS file for some of the more complex libraries like Redux Saga, I probably would have no idea how that thing works if I hadn't already read the docs.
Right.
But sometimes you have to, right?
Right.
I think that it's really important to start with the foundational types and understand as much as you can, and then build towards an understanding of the system. Like with any difficult task, like you can try to split it up into the things that are easier for you and then work your way towards the harder ones.
About
Yeah.
how long do you think it takes somebody to really like, understand the entire API of TypeScript? Like, especially like, let's say you're, like your job is kind of like being kind of like that person who explores kind of, the more harder parts of TypeScript. Because I think like the easier stuff is just kind of like, the variables, functions, the unions, I could say, are kind of pretty simple, straightforward. But then like you get into like the harder parts where it kind of like suddenly becomes like, massive D types files and stuff like that. And at that point, would you say it's TypeScript that's hard, or would you say it's just like the complexity of the library itself?
Yeah, I don't know how to answer that
read.
question. That's one of the questions we have like a lot of difficulty with at CodeAcademy. And like Sylvana, please like argue with me if I'm wrong here. Like how long does it take to learn a thing? Like, is it 5 hours? Is it 50? Like, do you measure in hours or days or work units? Like everyone's different and you don't want to give too big or too little of an estimate. So like I have been trained to not answer the question you just asked, because like some people will take like, I don't know, 15 hours and then they'll just be like TypeScript experts. Like they already understand a lot of the type theory. They like, it just clicks for them and that's fine. And then some people will take like a few dozen hours in total of work, or like hundreds. And that's like, they do it in their spare time. They don't focus on the types. Like that's fine too.
Gotcha.
I will say that I agree with the last thing you said, that a lot of the time it's more that the library is complex and not TypeScript. I think that a lot of the advanced TypeScript features on their own are actually really beautiful and clean.
Sure.
The head of TypeScript, Anders Hallsberg, who also made C#, is like one of those people that just likes the beauty of the language. So I think it really comes from the libraries more than TypeScript when they use it in a bad way, just like with any programming languages.
Yeah, makes sense. Okay. Joey says, sounds like the factor would be contingent on a person's ability to comprehend the object side of working with objects. Yeah, I can see that. All right. Well, without further ado, I think that was a great meetup. Thank you so much. Josh, you are really great with your TypeScript on the fly. Sylvana, excellent job too with React. I really enjoyed watching you, talk about it and doing the demo. And thank you to the audience, for just being engaging and, asking questions. It's really what this is about. I know a lot of people kind of say, oh, well, I can just watch the video later, but we really want to give you the chance, like, to ask the hard questions, especially, like, there's so many factors on the line too. Like a lot of you have questions, a lot of you come to me, a lot of you come to the group, and, you have like all kinds of different things that are on your mind. Sometimes like, rather than just going and reading a whole bunch of tutorials or trying to watch like 4 hours of the, tutorial video just to get one thing, like maybe it's just really quick if you can answer the question like in a 1 hour meetup and, get an answer right then and there. I think that's more effective. So, come here, ask your questions. Again, I'm VJ, I'm your host, for this group, JavaScript LA. Just really quick, run through this one more time for latecomers. The group is called javascriptla.net. If you want to reach out to me directly, you can find me on LinkedIn. And I'm just going to put my LinkedIn again once more in the chat. You can connect with me, ask me whatever questions you have, especially if you're trying to find a job, trying to like, get better at something. Because like, again, like I'm having the same stuff too, like, and I'm sure like everybody in this group is, we all want to get better. And if you want to find out where the video is, it's at youtube.com/hackbuddyorg. So I'm just going to put a link to that as well. We will get all the presentation and slides, and we will put that, in the video itself, as well as we'll also have it at github.com/hackbuddyorg. And you can go there and view past presentations. We usually fork off the presenter's repo. So you can go to the presenter's repo directly, or you can come to the hackbuddyorg repo as well. And yeah, just your single source of truth is going to be this website, javascriptla.net, if you're interested in more meetups, as well as programming together with Team Hack, which is our group that goes one step further than just watching and learning. Like, we also implement it and we try to code together in a fun way using GitHub industry standard techniques. And so it's a great way to just level up your skill. And then finally, there's going to be an email kind of like this that you're going to get in your inbox. And we just want you to tell us how the meetup was, because this helps us, like, understand, like, if you enjoyed this group, if you understand like the meetups, and what we can do better to make this better. So when you give us your feedback, like, that actually helps make the group better, so that we can make what we present here better, and then you get better. So that's really a 360 win, as I'd like to call it. So and one more thing, thank you to Farmers for presenting this or sponsoring us. And yeah, that's basically it. Did you want to add anything, Josh, Sylvana?
CodeAcademy has a TypeScript course, and we have a whole bunch of React courses. I'm sorry, I forgot to check with you if it's okay to plug CodeAcademy ahead of time.
That's perfectly fine. Yeah, no, like, you guys earned it.
Cool.
So
we also have
thank you so
really good
much.
SEO. So if you look up CodeAcademy TypeScript or CodeAcademy React, I really hope we're the first ones on at least DuckDuckGo. By the way, +1 for using DuckDuckGo. Privacy is important.
Yeah. Yeah, I love DuckDuckGo. And you said CodeAcademy with TypeScript, if I type that in here? Does that
Yeah,
work?
CodeAcademy TypeScript.
All right, here we go. That's awesome. I'll put a link to that in the chat as well. Perfect. Thank you so much. Everybody, thank you for joining. If nothing else, have a great night. All right, thanks a lot. Good night, everyone.